All right, so I think I'm recording. Let's take a look at these three problems. They're wanting us to find the discriminant and state the number and type of the solutions to the following equations. Let's write down our quadratic formula that we can have in reference to this. Remember that our quadratic formula is x is equal to the opposite of b plus or minus the square root. And underneath that square root, that's what the discriminant is. So this is the number that we're going to calculate each time for each of these problems. All right, so let's jump in and take a look at number one. Let's identify A, B, and C. A is equal to 2, B is equal to 5, C is equal to 2, because this is given to us in standard form. So this discriminant is b squared minus 4ac, and we can figure out what that number is. B squared is 5 squared, which is 25, minus 4 times 2 times 2. That's 16. 25 minus 16 is 9. 9 is a perfect square, so when we take the square root of it within the formula, you're going to have plus or minus 3. So we're going to have rational solutions. So find the discriminant. The discriminant is 9. State the number and type of solutions. There are two solutions, and they are rational numbers. Two real rational solutions. It's not asking us to actually find the solutions. We could continue substituting into the quadratic formula and simplify that fraction, but to find it, but it's not asking us for that. So here's our answer for problem number one. And we want to do the same thing for the other two. So in this next one, let's identify A, B, and C, because it's in standard form as well. A is equal to 1, B is equal to 10, C is equal to 8, and this discriminant, we know the formula. It is B squared minus 4 times A times C. B squared is 10 squared, which is 100, minus 4 times A, which is 1, times C, which is 8. So we have 100 minus 32. Wouldn't that be 68? Now, the 68 is positive, so it is going to be real solutions like the previous one, but see, the last one was 9, and that was a perfect square. 68 is not a perfect square, so therefore we're going to have irrational solutions. So we found the discriminant to be 68. 68 is not a perfect square. There are two real solutions, but because the 68 is not a perfect square, you're going to have a radical in your final answer. See, the last one, the radical 9, it simplified to 3. The radical 68, the radical does not go away. So we have two real irrational solutions. And there's our answer for number 2. In this next one, I notice that all of these terms are all divisible by 3, that 3 is the greatest common factor. So what I always do is reduce the numbers to make them smaller. 3 is not that large, and I can handle it, and I can do arithmetic on 3. But whenever I see the common factors like that, I reduce it just to make the numbers smaller and easier to deal with. Because my mental arithmetic, honestly, is not that great. So A is equal to 1, B is equal to -1, C is equal to +1, and from the quadratic formula, the discriminant is the part that's underneath the radical. It does not include the radical when I find that number. B squared is -1 squared. -1 times itself is +1, -4 times 1 times C. That's 1 minus 4. That's a -3. So the discriminant is a negative number. And within the set of real numbers, we can't take the square root of a negative number. We're going to have two solutions to this, however, but they're going to be two complex solutions. Complex numbers are numbers that are of the form a plus bi, where this I is the imaginary unit, and we define I to be the square root of -1. And we are going to return to this type of problem in skill packet 6 and look at complex numbers. So we will eventually solve this equation, but for now, we can recognize if they asked us for the solution that there is no real solution, and we can come to that conclusion quickly if we find the discriminant and notice that it's negative. We don't have to bother trying to plug in and calculate the quadratic formula. As soon as we know the discriminant is negative, we know that there's no real solution, that the solutions are complex numbers. All right, so I hope that helps, and I will talk to you later. Bye.